So these are instructions for how to fill out your Excel spreadsheet for the Borax post lab. So I'm going to show you literally how to fill out the spreadsheet step by step, and then what you'll need to do for your data analysis in order to complete the lab. So you'll want to download the Excel file for your class. It'll be posted on Moodle. This is one of our previous years' data, so this is not yours, but yours basically looks similar. In lab, you all filled out your initials, your temperature of the bath, the volume of HCl used to titrate your 2 borax solutions, and then your molarity, average molarity of your HCl. So that's all the orange area already filled in for you. What we want to do is we're going to fill in this green area with our calculations, and again I'm going to show you exactly how to do that. And then we're going to take that data, set it up so that we can graph it easily, and then from the linear regression of that graph you're going to pull some data. So do more calculations then. So in Excel, Excel is great at graphing and data entry, but what is also very helpful for us, or what Excel is used for, is to do calculations and data manipulation. So what we want to do is we want to do all of these calculations. The green area basically takes you step by step of the calculations that need to be done so that we don't have to do it all in one step. And we can do this, you can do this by hand, but you're going to have to do it for everyone's data. So it's a lot easier to force or have Excel do it for you. So when we want Excel to do a calculation, what we do is we hit equals. And anytime that Excel has this equals out in front, Excel knows then that it's going to perform some sort of function, mathematical, some sort of data manipulation, rather than just taking what you're typing in. Okay? So we want the temperature in Kelvin of this data point. So we want to, what we normally do by hand is we take our temperature here, our 31.60, and we want to add 273.15. Okay? Now rather than typing in this manually, we can say tell Excel that this is the data point that we want. So we're going to say equals, and we can click on it, and notice that it has the little ants marching around, and if you see behind it, it also has a colored box. And over here in our function here, or up in this area here, we see that it's equal B4. And just like the game Battleship, all your letters are up on top here, your numbers are along the side. So this is cell B4. So we want Excel to take whatever value is in this cell, and then we're going to add 273.15. We hit enter. Excel does this calculation for us. So I'm going to go through and do all of these calculations for just this top row, and then I'll show you how to apply it to all of the data points. Next calculation, we want 1 over temperature. So we're going to say equals. We're going to say 1 over. We want our temperature in Kelvin. So I'm going to either arrow over, or you can take the mouse and click on the cell that you want. So we have equals 1/E4. You can also type this in. So if you say 1/E4, okay, notice Excel is smart enough to go, hey, that's a cell location, and it highlights that cell that we're looking at. And then we can hit enter. Our moles of HCl, that's dependent on our volume of HCl used in the titration and the molarity of that HCl. So we're going to say equals, I'm arrowing over, or again you can click or type. We want the volume of HCl, so C4, and we're going to multiply that by the molarity of that HCl, so D4. And since our volume is in milliliters, we want it in liters, we're going to divide by 1,000. Okay, so our moles of HCl is equals C4 times D4 / 1,000. Our moles of our ion here, this is going to be half of our moles from HCl, so we have G4 divided by 2. Then our molarity of our ion is going to be our moles divided by our liters. So we have our moles. We're going to divide that by the volume of our borax solution. So that is the 5 milliliters from your calibrated test tube. We want that in liters, so we're going to divide by 1,000. I'm putting it in parentheses so that Excel knows to divide that value by 1,000 and not end up multiplying. And there is our molarity of our ion. Our molar solubility is going to be the concentration of our ion, or half the concentration of HCl. Okay, so it's just easy to use our ion concentration, so we're just going to use that same value that we just calculated. So equals I4. Our next calculation, we have the KSP of borax. If you look at the introduction section of your lab instructions, it shows what your KSP equation is. So it's the concentration of the sodium ion squared times our ion. So in the end, KSP is equal to 4x cubed, x being our molar solubility, which we've just calculated in our previous cell. So we can say equals 4 times our molar solubility, so 4 times the value in J4. To cube it, we hit the caret button, which on most keyboards is going to be Shift 6. So we have 4 times J4 caret 3. And that's 4 times the molar solubility cubed. We want the natural log of KSP, so we have equals. For the natural log, we can type in ln, and notice when I start typing in text, this box here is all of the functions that Excel can do that start with L. Okay, so we have a number of them. We can either click on this ln, or we can just type in ln. Okay, and notice it also gives us this little blurb. It returns the natural logarithm of a number. So this is an actual function rather than just doing addition, subtraction, multiplication, division. So we have our function, our natural log. We want to now tell Excel what numbers to use, and we want to put that in parentheses. Okay, so we have natural log of a number. Again, anytime that we need a number, we can tell Excel to pull that number from a cell. So we want it to pull that number from K4. We put our parenthesis around that. And now it's going to take the natural log of our KSP. Our delta G standard is the negative RT natural log of KSP. So we have negative, R value is 8.314. You remember the units on that to tell you what your units of delta G standard are. Negative R, we want temperature in Kelvin. So again, we can either type in the cell, click on it, or I like just using the arrow buttons. So we want our temperature, which is cell E4. So I just arrowed over to that. Now I hit the times button, and it doesn't automatically take me back, but I can scroll back over here. Okay, I'm still working in this cell. So we have negative RT, we want natural log of KSP. So we want our L4, and then we can hit enter. And that's our delta G standard for that calculation. And now our calculation is all done. Okay. Over here in the blue columns, so these are the blue ones, this is just repeating our columns so that it's easier to graph. So we can just highlight this data and have Excel start a graph for us. Okay, it says copy the data into these cells. I would rather pull the data or have Excel pull the data. If you copy the data into here and then later on you find that you have an error or you change something over here in the green, okay, if you copied the data, you would have to then recopy it because that data has changed. If you tell Excel where to pull the data from, then whenever you make a change over here in the green area, it will automatically make the change in the blue area. So we need 1 over temperature here. So we're going to say equals, and I'm going to say Excel find that data, that point in F4, since that's our 1 over T. We hit enter. Natural log of KSP, we want, say, Excel equals, go find natural log of KSP, and you'll find that value in L4. All right, so we've completed our calculations for one row of data. We now want to do these calculations for all of our data that we've been presented. So you can copy and paste, but there is an easier way in Excel. So we're going down to line 37 here. So what I want to do is highlight all of the green and the blue, okay, just of the data manipulation that I did, okay, just that one row. Over on the right-hand corner here, you'll see that we have a different square there, and if I put my cursor over it, it goes from this open outline of a plus sign to just a solid plus sign. And once you get this mouse cursor, then you want to click and hold and drag the corner of that box down so that you get down to wherever your last data point, which was row 37. So you guys, maybe I can turn this. I'm basically clicked and dragged down to, on the left-hand side, it's a little blurry, but it says 37. Release the mouse cursor, and notice it is filled in all of those data points. Okay, so if we look at this up here, right here, we can see where it's pulling the data from. Remember I said find this data point. This is in F7. Okay. Excel is smart enough so that when I clicked and drug that box down, Excel can figure out, oh, F4, there we go, wasn't scroll all the way up. Excel is smart enough to figure out, hey, you clicked and dragged this cell 1 down, so you probably mean to take that data point from 1 down. So here we have F4. If I arrow down, keep an eye up here on this section here. If we go 1 down to row 5, Excel knows to change where it's pulling that number to F5. Okay, and F6 and F7 and F8. Some of you asked in class today, at least in the 10:30 lecture, what those dollar signs mean. And the dollar signs are put either or both in front of the letter or in front of the number to force Excel to not change where it's pulling that data from. So if we wanted to copy and paste this down and we wanted to keep the data always at F4, we would put a dollar sign in front of the 4, and then each data point, even though we are copying and pasting it down a row, Excel will stay at F4. It won't change to the lower rows. If you put the dollar sign in front of the letter, if you copy and paste this way, it won't change and move to the right or to the left, regardless of where you're copying and pasting. In this case, we don't need the dollar sign, so we don't have to worry about that. So what you want to do is you're going to graph these two columns. This is your X value and these are your Y values. Okay, and check out your instructions, the introduction portion that shows you why you're graphing it. You're going to want to perform a linear regression, and remember the rules of your linear regression, that you want the equation and the r-squared value on that graph when you put it in your post lab. And the slope and the y-intercept are going to be where you extract your thermodynamic values from. So you'll get your delta H and your delta S from those values. Pay attention to your units and make sure you report the units, report the values in the units that are typical. So delta G standard, delta H standard are in kilojoules per mole. Delta S is in joules per mole. Joules per mole per Kelvin, excuse me. And what you're going to want to do for your post lab is report your values for delta H and delta S, as well as for delta G, all of those being standard temperatures. And you're going to want to show your publication quality graph, okay, using what you've learned this quarter to produce a good graph, and include that with your post lab, with your data manipulation and your values. If you have any questions or need any help with Excel, let me know. Send me an email or stop by my office. I would be happy to help you. Good luck and have some fun with Excel.